Happy Friday, everybody. Sorry I'm not here again. Baby Henrik should be here by now. I'm making this video beforehand, though, just so you guys are ready. But here is your bell ringer for the day. So please pause the video, take a few minutes to work through the bell ringer, and then check the answers. All right, check with the people at your table to make sure you get the right answers. All right, so on the first one, we want to find P of 3, okay, and P of -5. So that's just function notation. What does that mean that you do with the 3 and the -5? Okay, those are plugging in for x. You put them in for x, and then you see what you get. So you have to do two different function notation sets. All right, so P of 3, if we plug in a 3, 12 minus 3 squared, that's 12 minus 9, which is just a 3. So P of 3 is just a 3 after I plug that in. Now let's do the -5. So P of -5. Okay, plug that in. It's 12 minus a -5 squared. Be careful with your negatives here because -5 squared turns into a positive 25. So it's 12 minus 25. So P of -5 gives you a -13. Now, second one here is function notation again. But now we are plugging in a binomial to that polynomial. Okay, so we're plugging in x plus 2. So that will look like this. P of x plus 2 equals x plus 2, x plus 2. You could have written x plus 2 squared, but I'm saving some time here and just writing out x plus 2 twice because you have to FOIL it. Minus 3x plus 2 plus 4. So foiling this stuff out right here gives you x squared plus 4x plus 4. And then here's distributive property. So -3x minus 6 plus 4. Now I just got to combine like terms. Okay? So we only have that single x squared out front. Then we have 4x minus 3x. That gives you plus x, and then we have the 4 there, the 6 there, and the 4 there. So we got to combine those together. So 4 minus 6, -2 plus 4, that's positive 2. So that's your final answer right there, x squared plus x plus 2. Okay, that's stuff from yesterday, going over function notation, and you're plugging in a binomial. All right, this last one here is going along with graphing polynomials, which we're going to do a little bit more today. So you might need some graph paper for the lesson, or for the homework at the end of the lesson. All right, so the thing you're going to look for on these is your degree. What is the degree of the function? Okay, is it odd or even? Okay, well right here is your polynomial. What's the largest power of the variable? That's x. So your degree is a 2. Is that an odd or an even number? Okay, that's even. Then you can use your notes from yesterday, if you haven't gotten this far yet. Use your notes from yesterday to look at what even functions look like. All right, even functions look like this, or they look like this. All right, if we have a negative out front, that's like a -a. When you're thinking of parabolas, what does that negative out front do? That makes it turn down. So it's going to be an even one that looks like that. So using that thought process, your end behavior must be both negatives, right? So as x approaches -infinity, f of x approaches -infinity. And it's going to be the same thing going to +infinity. Okay, as x approaches +infinity, f of x approaches -infinity as well. Okay, that's your end behavior of that function. So that's your thought process when you're looking at polynomials. You want to figure out what the degree is. Then you want to figure out if it's odd or even. Okay, then from that, it's going to tell you if it's going to look like a parabola or if it's going to look like a line or one of those sideways S's that we drew yesterday. Okay? So now I want you guys to get out your homework, converse with each other, and make sure you guys work together to see if you have all the correct answers. You can look at the book at the front of the table if you need to, or the front of the room, but I want you to work through the homework for about 5 to 10 minutes to ask questions of each other at your table. So please pause the video. Okay, getting started here on the notes. Today we're going over 1.5 sections, so it's 4.6a. Alright, we're going to go over 4.6b. Oops. 4.6b after we get back from the break. So we'll spend some time reviewing the stuff from beforehand because I'm going to have some of that stuff on the next quizzes or tests or whatnot. Okay, so we'll spend some time reviewing that before we actually start learning the new materials. But we're breaking this section in half because it's a lot. So go ahead and write your title down there. Okay, pause the video if you need to. Okay? So the first thing that we want to look at when we're graphing polynomials is location of zeros. Okay, so we have what's called a location principle. Okay, so I want you guys to just kind of sketch that graph over there off to the right. Okay, that's like a sideways S there. That's one of those cubics. Okay, so take a few seconds to sketch that graph. And then we're looking at the location principle here. Okay, so what the location principle is we're looking at zeros. Okay, so on your graph, circle that 0 right there. Okay, so you're going to think about the y value. So if the y value here goes from negative to positive, okay, so if we're thinking here, down here, if I'm following this graph, I'm still below 0, so that's a negative. As soon as I get above that axis right there, okay, I'm following it back up, that red, as soon as I get above the axis there, then I'm positive. So if your y values are going from negative to positive, then there must be a 0 there, okay? The inverse applies also. That means if you're going from positive to negative, okay, so if you're crossing that axis going from positive to negative, then there must be a 0 there also, okay? So, first thing here, we want to look at graphing a polynomial. And if you guys need to go back and pause it, please go back and pause it, okay? But we want to determine consecutive values for x between which each real 0 of the function right there is located, then draw the graph. All right, so think about what we did for polynomials yesterday. We made an xy chart. So that's what we're going to have to do here, is we're going to have to make an xy chart. Remember when I said yesterday, when you're making your xy chart, okay, you're going to have to use more than your generic points. So I would probably do starting at -3, and then make your xy chart from there. All right? So I'm going to plug in all of those points. So you're going to plug in a -3 up here first. So it's -3 to the 4th. And this is going to be a lot of calculator work, okay? So minus -3 cubed minus 4 times -3 squared plus 1. So -3 to the 4th power. Okay, that's going to be a positive. It's 243. And then that would give me a -27, so I got a double negative, so it's plus 27. That's going to give me a positive 9, so I have -36 plus 1. All right, now you can see when you write these out, 243 is a big number, so you're going to end up with a big number. All right, so you don't always have to graph it. This one, we're just going to write it down in our XY chart, so we have extra points, but you get 271. Okay, just plugging those in. Now we're going to plug in the -2. So I'm just going to kind of keep erasing my work up here for my next points because I have an XY chart over here. Well, I guess I can write over here. I'll use my -2 over to the left here. Okay, so plugging in a -2 to the 4th minus -2 cubed. Okay, so -2 to the 4th, that gives you 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 16. We're getting smaller numbers here. So this is going to give me, if I have a double negative, that's plus 8. All right, this is going to be a positive 4. So it's minus 16 plus 1. So a little kind of quick way you can do here when you're looking from left to right with all the numbers that you have there. We have a positive 16 all the way to the left and a negative 16 off the right, so those are going to cancel out. So we have 8 plus 1, that just gives us a 9. So a much better number to work with. Okay, so take some time to fill out the rest of your XY chart. All right, so it might give you a couple minutes. See if you can fill out the rest of the XY chart and get your graph. Okay, so the XY chart is there. All right, so just filling in the rest of my numbers off to the right to copy that XY chart. -1, -1, 0, 1, 1, -3, 2, -7, and then 3, you got a bigger number again, is 19. Okay, without even drawing the graph, we can look at the Y values. Okay, where are we going from a positive to a negative or a negative to a positive? We're going to have one here, okay, and then we're going from here to here, because we went from a -1 to a +1, and then down here again, we went from a 1 to a -3, and then down here again. Okay, so that looks like we're going to have 1, 2, 3, 4 zeros. Okay, so the location principle says that somewhere in between there, okay, somewhere in between when it goes from a positive to a negative, there will be a 0. All right, it might be a perfect 0 where it's just a nice number, it might not be. But location principle just says that somewhere in between there is going to be a 0. So I'm going to plot my points. All right, so I'm going to use the nice one. So -2, 9 up there. -1, -1, so down here. 0, 1. 1, -3. 2, -7. And 3, 19. So that's just going to be kind of up there. So following from left to right, from the point that I started with, I'm just going to kind of follow that graph and hit those points. So it's going to look something like that. So let's look at how many zeros we got. We got 1 there, we have 1 inside there, we have 1 there, and we have 1 there. So that's right. If just looking at the XY chart, we got those 4 zeros. Okay? So you would say for your answer that for the first 0 here, it lies between 9 and -1. For the it lies between, lies between -2 and -1, because you're going to look at the x values, because zeros are x values. Okay, for the second 0, you're going to say that that one right here, okay, lies between -1 and 0. So for the third 0, that third 0 lies between 0 and 1. All right, and then the fourth 0, it's going to lie between 2 and 3. So that would be your answer. You'd have 4 zeros and you'd have to state the x values that they lie between. Okay? So I want you guys to try one on your own. All right, so pause the video. You guys need to make an XY chart and see if you can figure out where the zeros are. All right, back to the video. Okay, so you would plug in all those values, and I'm going to see if I can use a graphing calculator here. So it'll be x to the third minus 4x squared plus 2. All right, so if you make your XY chart, your generic XY chart, use my blue ink here again. So -3, you get -61, -2, you get -22, -1, you get -3, 0, you get 2, 1, I get -1, 2, I get negative 6, and 3, I get negative 7. Okay? So this one, when you get that far, let's graph those points and see what it looks like so far. So negative 3, negative 61, that's way down here. Okay, negative 2, negative 22, that's way down here too. Negative 1, negative 3, that's a nice point that we can graph. 0, 2, right there. 1, negative 1. 2, negative 6. And then 3, negative 7. So you can see that it's kind of leveling off down there, so it might turn back up. If I draw what I have right now, it's going to be way down there. It's going to come up here, and it's going to start to curve, and it kind of starts to turn a little bit. When you see that, you're going to have to do more points. So if I do a 4, and I plug that in, I get a 2. Okay, so that would be up here. 4, 2 is right there. So that means from down here, it's going to start to curve way back up and go that way. So that's what the graph would look like. So if we look at location principle, we're going to have a 0 here, we're going to have a 0 here, because we go from negative to positive. Okay? So we have that 0 there. And then here we're still going negative, negative, negative. Then you get down to here where it jumps to positive again. So that means you're going to have 3 zeros. Then you have to state the x values which they lie between. So it'd be between negative 1 and 0, then between 0 and 1, then down here between 3 and 4. Now when you're graphing this, you might ask yourself, well, how did he know to keep going? How did he know to do another 4? Okay, well, one way we know ahead of time is the end behavior of a function there. What degree is that? Okay, that's a degree of 3, which is odd. So if I would have kept going down here, okay, say we got this point down here, and we would have just, all right, that guy's just going to trail off down there. Well, what types of functions have the same end behavior? That would be an even function. We know that that's not right because this is odd. Okay? So that's how you know it's going to curve back up, because you're going to have opposite ends, opposite end behavior. Okay? So that's one way that you know that you need to do more points on your XY chart. Another way, you guys can use Desmos to check your answers. Okay, don't just write everything down from Desmos. Don't sketch it from Desmos. I want to see XY charts. Okay, so that is location principle. Next thing we're going to cover, relative maximum and minimum. Okay, share at your table what you think a relative maximum and minimum are. Okay, so take a couple seconds, take about 30 seconds at your table, so pause the video. Okay, relative maximum and minimums. If we just look at a graph, okay, you're going to see some stuff down there below, that's okay. Just looking at the graph there, maximums are top points or high points on the y, and minimums are low points, okay? So low points on the curve. So where you have a lower y value than everything else, okay? So maxes are high, minimums are low. Now when we're looking at this graph here off to the right, what can you say about the y values as you approach and pass a maximum and minimum? Okay, that's the next thing I want you to think about. What can you say about the y values? So remember, y is this. Okay, so take another 30 seconds at your table and talk about what happens to the y values as you approach and pass a maximum or minimum. Okay, so thinking about the values of y. All right, here, I am going up. So that means y values are increasing, right? So once I get to that maximum there, think about that football that I showed you guys on Tuesday. Up here, that's where it starts to change. So now your y values are going back down. Okay, so you can say that when you approach a maximum, that your y values are increasing, and then once you hit that top, it's decreasing. Okay? And the other way around, inversely, if I'm going down, okay, if I see that value going down and I get to a minimum, then that means it's going to start going back up. Your values will increase. That means it's going to be a minimum, okay? So maximums will be increasing to decreasing. And minimums will be the opposite of that. Okay, minimums are the opposite of that, so it'll be decreasing to increasing. Okay, so we're going to look at a graph here. I'm not going to have you guys graph this one, I'm just going to show you the graph. Okay, so right there we would have to graph x cubed minus 3x squared plus 5. So again, you do an xy chart, -3 to +3, or whatever we need to. You start out with that -3 to +3, and then see what your graph looks like. Okay, so this one, when I graph it, would look like that. Okay, so I'm going to look at my XY chart that looks like that, and we're going to look at the values. Okay, we're going to look at the values on the XY chart. I'm just going to cover up everything else right now because I don't really want to look at everything else. I just want to look at that XY chart because I want to be able to check or look at a chart and see if I can tell where my maximum and minimums are at. Okay, so let's look at the y values here. So I have a -15, the next number is a 1. So that's obviously going up. Okay, and then I'm going up even more to a 5. So when I get to the 5 and I look at the next number there, that 3, okay, and what's happening there? I get up to that 5 and I'm going back down to a 3. So since I go up and then back down, this one right here is going to have to be a maximum because I'm going up to that 5. I'm increasing to the 5 here, and then now I start to decrease again. Okay? So we got a maximum there at 5. Now I'm going down to 3, going down to 1. And then what happens as we get to the 1? It starts going back up because I hit a 5 then. So if I'm going down and then back up, that means that that one is going to be a minimum. Okay? So we should have a maximum at 5 and then a minimum at 1. Okay? And then we can also get the zeros here. Alright? Didn't ask for zeros, it just asked for relative maxima, relative minima. Okay? But remember, zeros are where your y values go from negative to positive or vice versa. Since we went from a -15 to a 1, that's going from negative to positive, so there must be a 0 there. Okay, I want you guys to actually graph this one. Okay, take some time, make an XY chart, -3 to +3, graph this one, and I want you to estimate x coordinates at which relative maximum and relative minimum occur. Okay, so pause the video, take some time to do that. Okay, so back at it. We have x cubed plus 3x squared plus 2. Making my xy chart for that. So if I just make my generic xy chart from -3 to +3. Okay, we're going to check our values here. So before we can even start, we know that this is a degree that is odd. Okay, and it's positive out front. So if I think about that sideways S, it's going to kind of look like that. Because it's an odd degree and we're going up here and down here. So it should look something like that when we're done for an odd degree. Okay, that would be the stuff from yesterday that we went over. Alright, so plugging in my points, I get, and I'm actually going to have to do more points than what I have here by looking at my chart. Okay, so I'm just going to put, I need a -4 still. I need a -4 down there. So negative 14 is what you get for negative 4. Negative 3, I'm just going to rewrite this because that is going to be a bad graph. Okay, making my XY chart. I'm going to start with negative 4 here. I think I might need extra points. Okay, and let's see what we got from there. So negative 4, we get negative 14. Negative 3, we get 2. Negative 2, we get 6. Negative 1, we get a 4. 0, you get a 2. 1, you get a 6. And then 2, you get a 22. And if you plugged in a 3, then you get even larger from there. Your 3 is 56. Okay, now we want to determine where we have maximums and minimums. And we don't have to worry about zeros, okay? Just relative maximums and minimums. So we're looking for increasing or decreasing. Okay? So as I look from here to here, I'm going from negative 14 to 2. So that means I'm going up. Okay? Here, 2 to 6, I'm going up. Here, 6 to 4, I'm going back down. All right? So if I'm going up, increasing for here, okay, and then decreasing here, that means 6 has to be a maximum. Okay, 6 has to be a maximum. So I got a maximum there, so let's keep going. So I have negative 4, so decreasing, 2, decreasing, 6, increasing. All right, so we got another one there. We went from 4 to 2 to 6. So what happens when we're decreasing and then increasing? That means this is a minimum. 0, 2 is a minimum. All right, so if you plot your points on the graph, so negative 4, negative 14, that's going to be way down there. Negative 3, 2. Negative 2, 6. 1, or negative 1, 4. And 0, 2. 1, 6, 2, 22. So that's going to be kind of way up there. So if I just kind of follow from left to right, we're going to be here, there, and then back up. So you could check your graph to see if you did it right. We got our maximum value right there, minimum value right there. Boom, you got it. Okay? All right, we're going to take a break. So, to the brain break. You can pause the video, stretch for a little bit, and don't go to the bathroom, just stretch a little bit, stand up, stretch out, that way you wake up. Alright, back to the video. So, this is another example that you might see on the homework, okay? So it's something with weight gain, it's a real world example of a polynomial. You'll just have to see if you can figure those out in the homework, send me emails if you don't get them. But the next section is solving polynomial equations. Okay, so this is where we're going to do some more factoring again. So starting out, solving polynomial equations, we got a couple of new patterns. Alright, so we have the sum of 2 cubes and the difference of 2 cubes. I want you to write these patterns down because these are factoring patterns that we're going to need. So sum of 2 cubes, right there. That's a cube, that's a cube. If you're adding 2 things that are to the 3rd power, or 2 things that are perfect cubes, then you do sum of cubes. If you're subtracting things that are 2 cubes, subtracting 2 things that are 2 perfect cubes, it would be a cubed minus b cubed goes into that pattern, okay? So write those patterns down, make sure you have them in your notes, put smiley faces by them, stars and circles, because you're going to use them in the future. So back to factoring. We want to factor that. So x cubed minus 400. Alright, so I look at these, and I'm going to ask myself, are these perfect cubes? Well, x cubed, you know that's a perfect cube. Now the 400, you might not know. Alright, so if you went into your calculator and you found the cube root button and you throw in 400, well, that's not a perfect cube. Okay, so that one cannot be factored. Okay? Now, I'm going to change this, and I'm going to show you one that can be factored, okay? Because 400 is not a perfect cube, and you can't really do anything with that to make it a perfect cube. So, let's change that 400 to an 8. Is 8 a perfect cube? Well, we could put it back in our calculator, all right? You could do cube root button, and then you can punch 8, and then you see, yeah, the cube root of 8 is a 2. So this is how I like to do this. Once I find out that they're two perfect cubes, I'm going to write what they are the cube of below them. All right, so I'm going to have x there minus 2, because I know that x cubed is that right there, and 2 cubed is 8 right there. So from there, I'm going to use my pattern. This would be this pattern right there. So x is going to be my a, and 2 is going to be my b. Now, I don't care about the signs, because the sign in the middle there, okay, that sign tells me that it's a difference of 2 cubes. The pattern takes care of the sign. Okay, so right here, this is going to be the x minus 2 is going to be my a minus b. And then I'm going to use the rest of the pattern. So the rest of the pattern here, I need to square the first one. So it's a squared. That's going to be x squared. And then I got a plus. And then I'm going to multiply those two that are in there, that binomial, those two terms. So it's going to be x times a 2, which would be 2x. All right, so remember, you might be thinking, well, that's a negative 2 inside there. I don't care about the signs because the pattern takes care of the signs. Okay, then a plus right there, and then I'm going to square the one on the back end. Okay, so that would be 2 squared, which is 4. So that would be it. Now you might be looking at that when you're done, and you're like, oh, well, can I factor it again? No. Once you're done with the difference of cubes, you can't factor it anymore. So that's your final answer. That's the factored form of 2 cubes being subtracted. All right, so let's look at one that might be a little more difficult. Something like that. So the first thing you want to do, remember, anytime we did factoring, you want to see if you can take out a greatest common factor. So between this one and that one, is there a greatest common factor? What can I take out of 24 and 3? Well, I can take out a 3. All right? And then what can I take out for the variables? Well, I got an x there and I got an x there, so that looks like I can take it out an x squared. All right, factor that out front, write what's left. We have 8x cubed plus, all right, the 3 is gone, the x squared is gone, so we have a y cubed. So then when you get to there, you got to ask yourself, do I have 2 perfect cubes in here? Do I got difference of cubes or sum of cubes? Yeah, because we just used an 8 in the last one, right? So 8 is a perfect cube, and we know that x cubed is a perfect cube and y cubed is a perfect cube. We got lots of cubes going on. Probably getting tired of me tired of hearing me say that. So we're going to apply the pattern. So that 3x squared stays out front. Now I got to figure out what my a is going to be. Well, what cube gives me 8x cubed? All right, well, we just did an 8. So we know that 2 cubed turns into 8, and we know that x cubed turns into that x cubed there. All right? So then same thing with the y. It's just going to be y. So the 2x, that whole thing is going to be my a, and the y is going to be my b. So then I have to apply that pattern, all right? That pattern was up there. You should have had it written down. It'd be a plus b, which is just sum of 2 cubes. That takes care of the sign. And then we do a squared minus ab plus b squared. So a squared, that's the 2x squared. 4x squared minus. Now we're going to take those two terms inside there and multiply them together. So it'll be 2x times y. So it's 2x y. And then now we're going to take that b, whatever our term is for b, which in this case is y, and we're going to square it. So plus y squared. Then you're done. Okay? You're done from there because you can't factor that anymore once you use the difference or sum of 2 cubes. Okay? So those are a couple examples of sum of two cubes or difference of two cubes. I want you to look at the next example here now. Okay, we'll just look at the one on the top here. Can you apply one of those patterns? See if you can factor it. Okay, look for greatest common factors and then see if you can apply the two cubes, difference of two cubes. Or sum of two cubes, whichever one it is. Okay, so pause the video, please. Okay, back at it. The way you got to figure out what your greatest common factor is here is I would start looking at things that go into both of those. All right, so 54, thinking of factors of 54. You know you can take a 9 out of there because 9 times 6 is 54. But you might not be able to take a 9 out of 128. No, I would start with taking out 2's. Okay, 54 divided by 2 is going to get you to 27. Then I would think about if I take a 2 out of 54, is that going to leave me with a perfect cube? Is 27 a perfect cube of something? Yeah, 27 is 3 cubed. All right, so let's take out a 2 for sure, because that's going to get us a 27, which is 3 cubed out front. And then let's think about the variables that we can take. We can take out x squared. All right, so that leaves me with 27x cubed. That one right there is good for my pattern, but we got to see if we get that on the second one. So 128 divided by 2, that gets me to a 64, and we took out the x squared, so we have y cubed. All right, now we really got the gears grinding here. 27 and 64, are those both perfect cubes? Well, they are. 27 is 3 cubed, and 64 is 4 cubed. Okay? So we can apply our pattern here. I'm going to put that 2x squared way out front. I know that 3 cubed is 27, and I'm going to tag that x along there. I know that 4 cubed is 64, and I'm going to tag the y along. Just like we did before, that whole thing is A, that whole thing is B. Then you apply the pattern. Alright, so it's going to be 3x squared, which gives you 9x squared, minus, is what our pattern says. You multiply those two terms together. 3 times 4 is 12, x, y, and then you square the back end. So that gives you 16, so plus 16y squared. And then you're done. You have applied the pattern that is sum of two cubes. Okay? So those are new factoring patterns there that we can use. So on the next slide here, got a lot more factoring patterns that we've used before, and I got one on here that's new, okay? And that's the one we're going to spend some time looking at. Okay, we got the new one, it's called factor by grouping. So let's kind of take some time to review here, okay? First thing that we've done, we're kind of getting good at this, hopefully. Greatest common factor. Okay, these are just the factoring techniques. These are what I'm going to talk about. Greatest common factor, that means you're taking out a common number and taking out a common variable. And it's going to look something like that when you do greatest common factor. Okay, if that's all you can do. So the second one we've done before. Okay, or we've done today. Okay, we did difference of two squares already. Okay, difference of squares, that's where you got a plus b, a minus b. That's one that a lot of people are kind of forgetting here. There were a handful of people that forgot that on the last test, but that one's the one that you use a lot. Now, we got two other patterns here that we're going to use a lot. And you wrote these down already. So sum of two cubes and difference of two cubes. So these are just special patterns where you have the least amount of terms, where there's only just two terms. Okay, there's only two terms there, and two terms there. They're binomials, so those are how we factor binomials. Then the next one, perfect square trinomials. Okay, those are just the ones that had the special patterns, and I said we didn't have to memorize those because we could get those by just doing normal reverse FOIL or SMILE method. Okay, and then there's the general trinomials there. That would just be the reverse FOIL or the SMILE method. Okay? Reverse FOIL or SMILE. Then the new one here, factor by grouping. Okay, I want you to write grouping down because that's a new type of factoring that we're doing. So factor by grouping. Okay, we're going to practice a couple of those, then we're going to practice writing things in quadratic form, and then we'll call it good. So stay with me here. Factoring by grouping. You don't have to write this stuff down. I just want you to write the word grouping down. Okay, and the thing to recognize here, whenever you have 4 or more terms, that's when you're going to use grouping. So let's look at an example of factoring by grouping. So please write this polynomial down. Okay, I'll write it down with you just so I can have a little bit of workspace down here. So I see 4 terms. We haven't done anything with 4 terms yet, but you did it as a bonus question on the last test if you remember. So when we factor by grouping, that means you kind of break it up into 2 separate polynomials. Okay, so factoring by grouping, you would look at the first 2 and do a greatest common factor, and then we would look at the last 2 and do a greatest common factor. So right here, let's do a greatest common factor there. What can we take out of x cubed plus 5x squared? The only thing you can take out is an x squared. So if I did that, okay, x squared, x plus 5. Okay, now I got the second one. What can I take out of here? Well, I can't take an x out, but I can take a negative 2 out. And anytime you got a negative out front, you always want to factor that out. And I guess I can't say 100% of the time, but most of the time you're going to want to factor out that negative. So if I take out a negative 2, I'm left with x plus 5. Now you should kind of see something happening here. So I went from 4 terms on the top, now I have 2 terms. So I cut the amount of things I'm working with in half. Okay, so now I want to look at this entire thing here, and now we're going to do greatest common factor again. So what is the common thing between this term here, okay, common thing between that term there and that term there? You should see the common thing is that binomial in there, that x plus 5. That's my greatest common factor. I can take it out. So it would look like this if I factor it out. Okay, x plus 5, because that's my greatest common factor, that goes out front, just like we did the x squared there and the negative 2 there. So the x plus 5 is out front, and then when we take that out of each of the terms, we have x squared minus 2. All right, before you're done, you got to ask yourself, is everything factored completely? Did I use all my patterns? Do I see any difference of squares, difference of cubes, anything like that? And here, you don't have anything else left to do. So that's your final answer. All right, so next example down here. I want you guys to give it a shot, okay? And you guys might need to help each other at your table if I can get that shade to disappear. Okay? You guys might need to work at your table to see if you can figure it out. So write out that polynomial there and see if you can apply factoring by grouping. So please pause the video. Okay, factoring by grouping with this one. I'm not going to rewrite everything out. I'm just going to use the polynomial I have here. We break it down in half. We got that piece and that piece. So what can I take out of my first piece here? Well, I can take out just an a, all right? And then I'm left with a plus 3y. The second thing here, all right, what can I take out there? It looks like I can take out a 2, all right, so I'm going to write a positive 2 I can take out, plus 2, and then a y squared. All right, so I have 2y squared out front, and I'm going to write what's left in my parentheses. So taking that out, I have an a left, and then I have a plus 3y. Then you should see something going on there. All right, do I have the same binomial there? Do I have the same binomial greatest common factor there? A plus 3y, yeah. So that's what's going out front, that a plus 3y, because that's the same thing between the two of those. And then I'm just going to write what I have left. I have a plus 2y squared. Now you can't do anything here, so you're done. That's factored by grouping. All right, it's not too bad. It's actually kind of easy if you do it a lot. Now some of them might be kind of bigger, but it's not too bad. Okay, last concept, quadratic form. All right, if you think about what things are quadratics, all right, your standard form of a quadratic is ax squared plus bx plus c. And we're just going to write things in quadratic form here. Okay, so we're going to make it look like ax squared plus bx plus c. So the example there, if you can see it, we have this stuff right there. We have to change that to make it look like a quadratic. Okay, make it look like something squared. So these ones might take a little bit of thought to figure out what you're going to do. Okay? But I don't think they're terrible. So the first one here, we got that polynomial. So go ahead and write this polynomial down. Okay, so quadratic form, remember I wrote that up top. We need to have something squared, and then we have something that's normal, and then just a constant on the back end. So really that 9 on the back end here, you don't have to do anything with it, okay? So let's look at the first term here. The x is really all I want to look at, okay? What power of x, all right? All right, let's think about what power of x squared would get you to x to the 6th. All right, so if I wrote x squared, I'm going to try to change that into x to the 6th. What power do I need to apply here? Okay, well think about when you have power to a power, you multiply them. So if I multiply 2 by a 3, that would get me to, and I got that backwards, I should switch the 2 and the 3 around. If I multiply a 3 by a 2, okay, because I want that squared on the outside, okay, it's because it should be x squared, and you can think of this right here, think of that as just your normal x. So it would be x cubed squared, and I would just have that 2 out front, all right, and I can do this because this right here is still x to the 6th. I still have that same thing in the problem. All right, and it'd be minus, and now I want to kind of do the same thing with the next one. All right, so what power of x to the 3rd here would give me that x to the 3rd there? It'd just be power of 1. All right, and then we just have that plus 9 on the back end. Okay, that would be it. Because we're looking for that ax squared, so this would be ax squared plus bx to the 1st power plus c. Okay, let's look at another one of these. I think these could turn out to be slightly confusing, okay, because we're just trying to figure out how we can make it look like a quadratic. So here we got x to the 4th, negative 2x cubed, negative 1. Go ahead and write that one down. Okay, first one here, how can I split that up to have something with a 2 on the outside? I want to split it up so I have a square on the outside. Okay, I got a power of 4 there. So changing it to a quadratic, I can be like x squared to the 2nd power is going to get me to that 4. So this would be my ax squared there. Okay, then we got to do that bx, all right, so this would be minus 2x cubed to the 1st power, and then we just have minus 1 on the back end. Okay, so that would look like a quadratic or quadratic form. Now you might want to double check those in the book later on. I don't think I gave you very many of those. But you might want to look at those to see or review how to do those, because we're going to use those when we do use substitution later. Okay, and that would be on page 277 there. And I might have to double check that. I might not have done it right. I know this one up here is correct. Okay, we would have x cubed. And the one on the bottom, actually the one on the bottom when we're looking at that, these have to be the same when we're doing quadratic form, okay? And here, I don't have those as the same, so really, you cannot write that in quadratic form, okay? Because there's no way that we can get this x squared to an x to the third like that, okay? So this one wouldn't work, no solution. But the one up here, since we have the same number there, or same polynomial or term there, that one actually works. So you got to make sure when you're writing these in quadratic form that you use the same power of x there. Okay? And again, it's on page 277 if you want to review it later. Okay? Now, on Monday, you guys will do some review in class. And I think the majority of what you have on the quiz on Tuesday will be the stuff that we did when I was here. Okay? I will have a couple polynomial graphs on there because that's just simply making an XY chart from -3 to +3 and then identifying end behavior, which you guys have done before. Okay? Some of the stuff at the beginning of this lesson right here, 4.5, 4.6a, isn't super difficult. It's just graphing a polynomial and figuring out what it looks like, where your zeros are, where your maximums and where your minimums are going to be. Okay? That type of stuff is going to be on there. The factoring, I might have some of the older stuff for factoring, and I might have one for grouping on there, because grouping is not super difficult. The quadratic form stuff, don't worry about that for now. Just look at it in your homework, and we'll do that again when we come back from break, all right? So you guys will have a review on Monday, so come with your homework done and come ready for a review. And then that quest is going to be on Tuesday. So there is your homework, okay? Seemed like a lot, but a handful of these in the second one are just graphing, or not graphing, they're just factoring. And then a handful of these in the first section here are just looking at a graph, and then you're identifying zeros and you're identifying where the maximums and minimums are. So give it a shot, let me know if you got questions.